okay? All right, now let's look at the examples. So example number 1 is let's just read the statement first and see if you can understand what case it is, okay? So a recent government study reported that a college degree is worth an extra $23,000 per year in income compared to what a high school graduate makes. So it said if you got a college degree, you're gonna learn 23,000 more. Earn 23,000 more per year than if you got a high school degree. Okay, which makes sense. And if the interest rate I is 6% per year and you work for 40 years, what is the future compound amount F of this extra income? Okay, so sounds like you have 23,000 per year as income, and that's the same amount occurred every year, so we can say that's annuity, right? And now you want to know what is the equivalent value F of that annuity. You want to know after 40 years how much more you can earn. Okay, how much more you can earn the total compared to a high school degree. Okay, so the first thing is you want to draw a cash flow diagram. Okay, so to draw that diagram, you need to have a viewpoint, perspective. So let's say the viewpoint is you save 23,000. That's the extra, okay? So we're just looking at the extra. So you say kind of like you can save 23,000 more every year into your bank account. And that account gives you I equals to 6% interest rate, okay? So you can think of this problem as this. So you save the same amount of money every year into your bank account at an interest rate. So you want to know after 40 years how much you can get from that account. Okay? So let's draw this diagram. So you have your timeline starting at 0, 1, 2, 3, and then because it's so many years, so I would just represent the year in the between like that, and then you got 40, and before 40 you got 39. This is just a way to make it shorter, okay? And then because you're looking at this from your point of view, so you save 23,000 per year into the bank account. That money is out from your pocket, okay? So it's cash outflow. So it's arrows going downward. And also they're all the same length because they are the same amount. And it occurs at the end of the first year, and it continues until the end of the 40th year, right? And then you want to just write the A equals to 23,000 so that you don't have to label this amount for each of the arrow for 40 times. But you still want to write the I of 6%, okay, above or beneath this timeline. And your question is, what is the future amount of this given annuity? So your future amount is gonna be the lump sum money you can withdraw from this bank account. So that's gonna be an arrow going upward, but it's unknown, so it's a dashed line. And then you can write F equals to a question mark. That's the way you draw the diagram, the cash flow diagram, okay? Based on the cash flow diagram, now we can use the method. I would use the factor method, okay? So now we're finding F given A. So F equals to A times a factor. And that factor is what? To find F given A, given I, given N, okay? And then you need to find out what is A and what is the factor value. So A is 23,000. That's given. And what is the factor value? So F slash A and I is 6%. You just write it there. And N is 40. Okay, so that's the factor you want to find out from the table. Now let's look at the table. So we said I is 6%, so we use this table from the appendix C. And then the problem is to find F given A. So this is your column, okay, F slash A. And also which row, because you have 40 years to compound. So N equals to 40, that's your row. And then you can look up this factor value. So 154.7620, that's the factor value you need to use. So you continue the calculation. 23,000 times that factor value you just found out from the next page, okay? So that value is 154.7620. Use your calculator, do the calculation, and then you will find out the final result is 3,559,526. Wow, that's a lot, right? So please work hard on your college degree, because that will give you this much, 3.5 million more in the end of your 40 years of work. Okay, that's a lot. I'm so surprised. All right, so this is the first example. Okay, and then this is the second example. So still, let's read the statement and see if you can identify what scenario it is. Okay, a microbrewery is considering the installation of a newly designed boiler system that burns the dried, spent malt and the barley grains from the brewing process. So it sounds like this is a new type of boiler which can save you some money, because you can recycle the whatever you produce or you have from your brewery business, right? The boiler will produce process steam that powers the majority of the brewery energy operations, saving. Look at that. So the new boiler can save you this much per year over the boiler's expected life of 10 years. So every year you save the same amount for 10 years. That sounds like annuity, right? If the interest rate is 12% per year, how much money can the brewery afford to invest in the new boiler system? Okay, so how much you can pay, how much you would love to pay for this new boiler, so that you don't lose or you don't pay too much. Okay, so the way you think that is, you save some money every year for 10 years. How much in the total you have saved? That should be the same as how much you paid at the beginning to buy it, right? Of course, you want to pay even less at the beginning so that you have a better deal because you saved more, you paid less for it. But you have an upper limit of that payment, and that's what you want to know. So, at least you need to pay the same as what you can save in the future. That's the point, okay? So the problem equals to you want to find out the present value of that saving amount for 10 years. What's the present value of that cash flow? That's your real problem. So that is to find a P when given A. Okay? So still the first thing is you need to draw the diagram, the cash flow diagram. And the way you look at this, the perspective is from your perspective. You're the brewery. Okay? So from the brewery perspective. Okay? And then draw this diagram. So we have a line, and then we have 0, 1, 2, 3, and then I don't want to draw the long line, so I will use this zigzag symbol to represent all the years in between. And then I got 9, and then I got 10. Okay, that's the whole timeline. Because you're looking at from the brewery's perspective, so at the beginning they need to spend some money, and then every year that they can save some money. So the savings are kind of receiving the inflow, right? Cash inflow. So the saving of the 450,000 per year, it should be the cash flow going upward. So you want to draw the same length of arrows for all the 10 periods. And then you write A equals to 450,000, right? And then you say the I equals to 12%. And what you want to know is at the beginning how much you want to pay, how much the brewery want to pay. So you want to find out the present value, and the present value should be the money giving out, so it's going downward. So what is that? Okay, so it's to find P when given A. That's the scenario you're looking at. So you're going to use this equation. Okay, so P is A times a factor. Let's practice. The factor is to find P given A and I% and N. Okay, so what is A? A is 450,000, and you just use the values of I and N to substitute the letters. So I is 12%, N is 10. Okay, so now you need to find out the exact factor value from the table. So the table is the I equals to 12. That's the table. And then you want to find out the column. Column is to find P given A. And the row is N is 10. So this is your factor. Okay, so 5.6502. And do the calculation. You will find out the result as 2,542,590. Wow, that's so expensive, I would say. Okay, but that's the upper limit amount you want to pay for this boiler, okay? So that what you gain from using that is equal to what you have paid. But if you are good businessman, you can negotiate the price and you might get a lower price than this, which means you pay less and you save more. Okay, that's a good deal. All right, what's the next? Okay, so now it's the example 3. Let's just read through it, okay? So you borrow 15,000 from your credit union to purchase a used car. And the interest rate on your loan is 0.25% per month. And you will make a total of 36 monthly payments to pay it off. So what is your monthly payment? Okay, that is very useful scenario when you're going to buy a new car. Okay, so this is actually to find out A when given P, because the money you borrow now is kind of present value, and then you want to know like how much you pay it back every month. That's the annuity. So that's this scenario to find A given P. The first thing is you want to draw this diagram, the cash flow diagram. And you can choose to use your perspective, of course. So your perspective to draw this diagram. So you want to draw a timeline. 0, 1, 2, 3 until the 36. Before that it's the 35. Okay, and then you borrow 15,000. So from your perspective, you get 15,000 into your pocket. That's the inflow. So that's arrow going upward. So it's like this. And that's the P equals to 15,000. Okay? And the I is what? Is 0.25%, which is pretty low. And also, what you want to know is how much you pay every month. So, and the money you pay is the money going out from a pocket. That's the cash outflow. So it's going downward. So you want to draw a dashed arrow for each period, okay, until the end. And then you want to say A equals to what? Because you don't know, so that it's dashed. And then, so now you want to use this equation, okay? So A is P times a factor. That factor is to find A given P and I% and M. So what is P? P is 15,000. That's given. Times A/P. What is I? I is 0.25%. N is 36. Okay. Now you need to find out the table in Appendix C and find out this factor. Okay, so that table is here. 0.25% is a quarter, okay? And then you want to find out A given P, so this is the column. And how many periods? 36. Okay, so let's just see which is, so this is the factor you want to use. And that factor is 0.0291, which is 436.5 per month. So that is your monthly payment to that loan, okay? Which is very useful. All right, next. Now let's just, have a pause and then let's try to summarize everything we have learned until now. Okay, so we learned how do we find the future value given a present value. How do we find out the present value given a future value? Okay, and then today we have learned how to find out the future value given annuity. How do we find out the present value given annuity? And also, how do we find out annuity given the future value, and how do we find out annuity given the present value? To me, it's just like to convert the value at different times to another time spot. Okay, so I always say convert this value to another value. And we learned the equation method. So these are the equations you can use. But we said we want to always use the factor method. Okay. But to use the factor method, you need to learn how do you write the factor functional symbol. How do you write the factor first? So I want you to just look at this table and then try to write the factors, okay? And then I want you to practice that on this blank page. Okay, how do you write the factor for this one, and this one, and this one, all of this, okay? So this page is for you to practice. You just make a pause and then fill the blank parentheses here and compare that with this page to see if you truly understand how to write this factor.